Hello, and welcome to today's lesson, working with proportions, similarity, and congruence, lesson 1. So we're going to be doing some review of some previous topics that we've had and, using that to make extensions into new material. So by the end of this lesson, we'll be able to do the following: review the meaning of ratio and proportion, practice solving proportions, and use ratios and proportions to solve word problems. Okay, now, what we want to understand is the fact that when we're saying we're taking a break from geometry to learn about ratios, ratios are one of the most important pieces that we can use in geometry. We saw this back when we were dealing with the 45-45-90 triangle, the 30-60-90 triangle, that we could use equal proportions to set up and solve. So we're really just doing an extension of that and looking at some different situations here to be able to set up and solve those situations. When we look at proportional figures, we're looking at the Egyptian periods are built proportionally, Vitruvian Man, Mona Lisa, okay, all dealing with the golden ratio, okay, where we've got a rectangle with a length roughly 1.5 times its width, okay, and that shape is a shape that we see a lot of in construction because it is the most pleasing shape to the human eye. Okay, so now we work with proportions basically anytime you go out shopping and you're trying to make that decision between do you get the regular size or do you get the larger size. And what happens in these cases is we want to set up the ratio and simplify it down to the simplest form. So if we're looking at these bricks of cheese, we want to do cost per ounce and figure out which one is a better option. I'm going to pause this quick here so I can bring up the calculator. Okay, now that I got the calculator started up, we want to think about these ratios. We can spend $2.30 for 8 ounces, or we can spend $8 for 32 ounces. So when we want to find out which one of these is a better deal, we want to simplify it down to its simplest form, $2.30 divided by 8, because what we're going to get here is a cost per ounce for the cheese. So in this scenario, the $2.30 for 8 ounces works out to be 0.288 cents per ounce. Okay, we don't want to go too much further than 3 decimal places when we're talking about money. And then when we have $8 divided by 32 ounces, okay, we can see that that scenario is equal to 25 cents per ounce. Okay, so you're saving money in the long run as long as you can use up the 32 ounces of cheese before it goes bad. So you always have to keep that in as a part of your decision. Okay, so now, just like we talked about when we were dealing with the triangles and using proportions there, okay, you want to be able to work with fractions and set up the fractions properly. Okay, once we've done that, we've got our ratios, and then we cross multiply and solve. So that's why the proportion is such a powerful tool, because the process works basically the same way every time, and we just have to make sure we're setting up the ratios or fractions properly. Now, when we talk about a ratio, we can actually list a ratio in a number of different ways. So you can see these in any scenario. So we can have A over B. This is the one that we use most mathematically. But we can also have A to B for a ratio. Or we replace the word to with a couple dots. Okay, in mathematics, we're always using symbols to write things in a simpler form. So when I talk about 3 sugar-free monsters for $5, okay, I can always do that in any of these methods. So we've got 3 over 5, 3 to 5, 3 dot dot 5. Okay, so we can use those pieces. Okay, a couple of reminders about ratios. There are no units on ratios. Okay, and we always want to reduce ratios to their lowest form. Now, when we use our cross multiply and solve, why does that process work? Okay, the process of cross multiplication works where if we know the two proportions are equal, even though the numbers look different, okay, if we cross multiply and solve 7 times 40, 280, or 14 times 20, 280. Okay, when we cross multiply, we get equal values if the values are proportional. Okay, so that's why the cross multiplication works for us to be able to solve, is because the two fractions give us equal products. And if the equal products are there, then we can solve for a missing value. Okay, so using cross multiplication to solve these. Okay, here is one of our more basic problems. We've got 2 times x equals 7 times 3. Okay, so just writing it out first, thinking about those full steps. 2x equals 21. And then we divide both sides by 2, and x equals 21 halves. Okay, and that is in its simplest form. If we want, we could turn it into a decimal value. Okay, that's always dependent upon the situation. Okay, 10.5. Okay, but you can always just leave it in its simple fraction form of that 21 halves. Be careful of a problem like number 2. Okay, when we're looking at this situation and we cross multiply and solve, it's 4 times the quantity x plus 2 equals 3 times x. And this is a situation where we have to distribute the 4. Okay? If any mistakes are made, that's always the first thing I'm looking for. And what we talk about is when we're doing cross multiplication, okay, it's always going to fall back on the algebraic work to solve the rest of the equation. Okay, I'm moving the 4x to the right-hand side just so I have numbers on one side and variables on the other. We wouldn't want to leave it as a negative x. We would want to divide by a -1 to get our solution for that situation. Just some more cross multiplication. Okay, we have to be careful of what some things can happen. Notice that we can have a variable on both sides, and it just, allows us to do an extra step process-wise. So we cross multiply 2y equals 3 times y minus 3. We have to distribute the 3. Okay, and then we solve. Remember, variables on one side, numbers on the other. So I'm going to move this 3y. Really be careful of your signs. Okay, we use addition, subtraction to move the values. And then we always have to use division when necessary to finish the problem. Okay, so we've now solved for y. A problem like number 4. Okay, a good thing to remember when we're dealing with some other skills. So we've got 60 plus 21, x squared equals 81. And if you remember, we've worked through our perfect squares in that last unit, simplifying radicals. How do we simplify a squared value? We square root that value, and we get x equals 81. Now, in some cases, we can consider it a plus or minus 81. Okay, in most of these situations, especially if we're dealing with a real-world situation, we would want to use only the positive, not 81. How about we try this again? Plus or minus 9. But we'd only want to use the positive value because that's the only value that would have meaning in a real-world context. Okay, now, Where is this going to go in the problems that we're going to work with? We're going to start dealing with equal proportions of triangles and other shapes. Okay, and we want to find the ratio of the perimeter between the two shapes. Okay, so if we want to find the ratio of the perimeters, that's going to be the first thing that we have to do is find our perimeter values. Okay, our perimeter values, 5 plus 12 plus 13. Okay, so we've got 25 plus 5 is 30, is the perimeter of the first triangle, divided by the perimeter of the second triangle. So we've got 26 plus 24 is 50. 50 plus 10 is 60. So we have 30 over 60. Okay, but remember, we want the ratio in simplest form. So 30 over 60, we can divide both of those by 30, and we can work it down to 1/2. Okay, now, one thing to notice. Perimeter is a measurement of distance. So I could have actually got this answer by only looking at one pair. The short leg of 5, the short leg of 10, I could have set that up also to get the distance. Okay, so when we're looking at a distance value, perimeter, we can add up and get the full distance, or we can look at two of the distance pieces and set up our proportion from there. Now, ratio of the area of the triangles. Okay, so once again, the first thing you can do, and it's always the best way to do it, find the area of the two triangles. So area of the first triangle, we have 1/2 5 times 12. So we've got 60 divided by 2 is 30. So that's the area of the first triangle. The area of the second triangle, be careful. Don't get fooled to think that it's 60. Okay, 1/2 10 times 24. Okay, so when we do that, 1/2 of 10 times 24, we've got 1/2 of 240, or 120. Okay, so now we've got our area values, and we're just going to turn them into a ratio. And then from there, we want to divide both by 30 because we want to get that ratio into simplest form. Okay, now, one thing we also want to notice is just that relationship piece. What we have, 1/2 and 1/4. How are these two pieces related? 1/2 is a ratio of distance. 1/4 is a ratio of area. Now, how do we get area? Area in its simplest form is length times width. So if I have a 1/2 ratio for one measurement, and it has to be a 1/2 ratio for the other measurement, I multiply those two together, and that gives me my area ratio. Okay, remember, the simplest way you can do it is to find the two separate areas and set up your ratio from there. But if you do know the ratio of the lengths, the ratio of a distance, you can multiply that ratio times itself and turn it into the ratio for your areas. Okay, now, just a couple quick examples here to wrap up, looking at the real world situation here. So we've got a photograph. Dan is 2.5 inches tall. Okay, his sister Emma is 1.5 inches tall. And we know Dan's actual height is 70 inches. Okay, so one thing that we want to be careful when we're setting up our proportions is that we're putting the values in the right spot. Okay, we want Dan, and we could have this flipped around as well, but we want to make sure that Dan is on one level, Emma is on the other, and then we want a ratio for the picture and the ratio for the actual. So the picture, Dan is 2.5, Emma is 1.5, and notice I'm just using these headings to make sure that I'm really lining things up properly, because if you don't, there's no way to get a right answer if you don't set up your proportions or your ratios properly. So Dan is 70 inches tall, and we're trying to find Emma's height, so that is our x value. Okay, so now, to finish the problem, what do? We've got our equal fractions, and we cross multiply, and we'll solve from there. So 1.5 of 70 is 105, because I've got 170 and half of 70. Okay, we can always multiply that out on the calculator, let the calculator do the work for us. 1.5 times 70 equals, oh, forgot the time sign, 1.5 times 70 equals 105 divided by 2.5. Okay, and we find out that Emma is 42. And now this is where it's important to make sure that you label your answer. 42 inches tall. Okay, construction blueprints, another place where proportions, fractions are being set up to solve situations for us. Okay, so Matt is drawing a floor plan for his new house. The conversion he is using is for the floor plan, 1.5 inches equals 3 feet. Okay, so now what you want to do is, okay, so we've got the floor plan measurement, real measurement. Okay, so that is the measurement there. Okay, so what is the dimensions of his bedroom if he draws it 5 inches by 10 inches? Okay, so now we got to set up two proportions for this situation. So we have, and remember, the 5 inches is for the floor plan, and then we've got the real world is what we're trying to solve for. You know, so this is still just measurement, but we have to make sure our floor plans are together and our real worlds are together when we're setting up our ratios. And then we cross multiply and solve. 1.5x equals 15. Divide both sides by 1.5, and we get x equals 10. Okay, so we have a 10-foot measurement for the one dimension. And then we're going to have to set up our second proportion, okay, because it's 10 inches the other way. So we've got 1.5 over 10 equals 3 over x. Okay, now pause here for just a second and think, do you know the answer to this question? You might know the answer already. X equals 20 feet. So this room would be 20 feet by 10 feet for the dimensions of the actual bedroom based on the drawing of the bedroom. Okay, that is our end of lesson here, looking at ratios, proportions, and using them to solve real-world situations. Thank you and have a good day.